All right, so this next type of transformation is called reflecting. And we're talking about reflecting over the x-axis or reflecting around the y-axis. So this involves inserting a negative somewhere in the function. If we just put a negative in front of the function, that reflects it around the x-axis. If we put a negative in the function, for the input. So instead of x, we have negative x. That reflects it around the y-axis. And so you can see this one flips it upside down. This one flips it around. It could flip it left or right. I mean, it depends on how you look at it, I guess, but flips it around the y-axis. So let's see what this looks like. We have f of x equals x squared, or negative x squared, I should say. So we have the negative in front, so that is going to flip it over the x-axis. So there's our x squared, and then if we want to do negative x squared, that will just flip it upside down. And so all this is doing is, if you have x squared, y equals x squared, all of those y values are positive because you square any x, and y equals x squared, so you square the x's, it becomes positive. Now, all these values, because you're going to square it and then put a negative in front. And all these values are going to become negative. So instead of having, say, 1, 1, or 2, 4, or 3, 9, all of these are going to become negative. All right, what about square root of negative x? So that is inside the function. Here, this negative is outside the function. This negative is inside the function. And so instead of this, we're going to reflect around the y-axis, and it is going to look like that. And it's as simple as that. So this domain, recall if you have square root of x, y equals square root of x, what's the domain? It's all positive, well, should say non-negative numbers. You set what's under the radical greater than or equal to 0 and solve for x. If we have y equals square root of negative x, now we're going to say negative x has to be greater than or equal to 0. Solve it for x, divide by the negative, and flip the inequality. So x has to be less than or equal to 0. We can also do, well, maybe we'll do those later, but if you started over here and reflected it, then you would be over here. So it is a true reflection around either the x or the y-axis, depending on which one we're looking at. So the next one, vertical stretching and shrinking. So y equals c f of x. So again, we have the c outside. If it's outside the function, it's always talking about a vertical. If it's inside the function, it's always talking about a horizontal. So if c is greater than 1, we stretch the graph vertically. So we make it thinner. It looks thinner. That would be right here. So here it's kind of flattened. I mean, it flattens out, I guess. This one is going to be taller because you're multiplying that y value, that original y value, you're multiplying it by a constant. And so this is the original x value with the original y value. Now you're multiplying that y value by some constant. And so it's going to get farther from the x-axis. And then if c is between 0 and 1, then it's going to shrink it. And instead of being up here, it's going to shrink it down there. And of course, we don't have to worry about the negative. The negative flips it upside down. So, -2 stretches vertically, just like +2 does, but the negative would flip it upside down. So that's kind of two transformations there. So if we have y equals 3x squared, we have x squared like this, and then the 3 is going to stretch it vertically, and it'll look like this. And so instead of 1, 1, if it's y equals x squared, we'd have 1, 3. If it's 3x squared. Instead of 2, 4, we'd have 2, 12. And then if we have h of x is 1/3 x squared, here is our x squared, and then this is going to shrink vertically, and this makes it flatter, like that. So instead of 1, 1, So if x is 1, y is 1 when we're talking about x squared. If we're talking about 1/3 x squared, when x is 1, then y would be 1/3. So the y value goes down. All right, and then next one, we are talking about horizontal. So to graph y equals f of cx, if c is greater than 1, we shrink the graph horizontally by a factor of the reciprocal. If c is between 0 and 1, we stretch it horizontally by a factor of the reciprocal. So you can see here, if c is greater than 1, we have the original blue graph. We are going to compress that down. And so instead of the x-intercept being, say, 1, it would become 1/2 because we have this c in here. And if the c was 2 and x is 1, or I should say, well, if c is 2 and x is 1, then the y has to be half of what it used to be. So if we look at this and this won't be exact, but you can kind of get, we'll put a 1 here and a -1 here just for perspective, because the original one is 1 there. And so if we have, so c is greater than 1 here, so we are going to horizontally shrink it. And so basically we will have 2 of these. We'll have 2 of these over the space of 1 unit as opposed to 1. So it's going to horizontally shrink it. Then this one, 1/2 x, we are going to have, it is going to take 2 units to go, one of these cycles. So it's going to horizontally stretch it out. So it doesn't get taller, it just horizontally stretches it out. All right, so let's stop there. We'll do one quick one after this one.